minutes per second. Okay, so 67, linear speed, angular speed. Computerized spin machine rotates a 25-inch diameter, 25 inches. And most formulas don't use diameter, they use radius. So I'm going to go ahead and change this over so I don't forget. Most of the time you guys don't forget that, but I did see one person on yesterday's quiz in my other classes did do that. I forgot to divide it in half. So we'll do that, get it over with. And it rotates at 480 revolutions in 1 minute. Okay, so that's how fast it's turning. So yes, it's the speed, but you can know if that's linear speed or angular speed. This is how fast it's turning. We're giving the angular speed. Okay. For Abe wants to know, find the maximum angular speed. Angular speed. In radians per, I'm looking for a question. Find the road speed in miles per hour. Okay, so road speed, what is road speed? That's linear speed. Joseph, you'll need to remind me. Okay, so they want us to do road speed in miles per hour. So I have not modeled this for you this year, but sometimes it's good to go ahead and just like leave a blank at miles per hour so you remember what your answer is supposed to look like. Alright, well they give me angular speed and they want linear speed. Well, there's only two formulas that you have to memorize for this. So one of them is arc length. Arc length, this is S equals arc theta, and the other is that linear speed is angular speed times r. Okay, I got angular speed and I got r, so let's multiply them together. And if you're not keeping up with your units, I would see why you might think that your answer is whatever 480 times 12.5 is. Because that's angular speed times r. And it is linear speed, it's just not in miles per hour. It's in revolution inches per minute, which is nonsense. No one calls their units revolution inches. So the majority of this work, my 3 or 4 steps left, because this is an easy formula to memorize. You plug in the two things given to you. That's not difficult, but changing the units can be. So I want to get it to hours. So I'm got it in minutes right now. So what can I multiply by to change it per minute to per hour? 60 minutes is the same as 1 hour. Of course, 5 minutes to go away. Okay, so I've inched my way to the right units. I've now got to revolution inches per hour, which is still not correct, but it's closer to miles per hour. Okay, also, I can take inches into miles, and if you know how many inches are in miles, I guess you can do this in one go. I don't bother with that, because I know 12 inches is 1 foot. So that changes it to feet. And then after I get it into feet, I can change it in from feet to miles. Okay, so then that would make my feet units cancel. You'll use all that while I'm doing what I'm doing there. Okay, so that's still not exactly right, but I'm getting it pretty close because I've got units in my numerator to be revolution miles, and I've got the units in my denominator to just be hours. So I've got my miles and I've got my hours, but I still have this revolutions. So can I just ignore revolutions? Then what unit was it that I could ignore? Radians. So if I can somehow change revolutions to radians, then that's my way of getting rid of that, or making it look different. If I say 1 revolution, it's the same as 2 pi radians, and since radians are the blank unit, I don't even have to write radians. So changing inches into feet, feet into miles, that's not new. Changing minutes into hours, that's not new. The only conversion thing that should be new to you is changing revolutions to radians and radians to revolutions. That's why I asked you to highlight that in your notes. Okay, now that I see all my units matched up, now I haven't touched the calculator yet. Now I'll let my calculator multiply those fractions for me. So if I multiply all the numerators, it's like 720,000 pi. And if I multiply all my denominators, it's 12 times 5,280. Those are big fractions, so I'm going to reduce that. So if I left it in terms of pi, I don't know what the back of the book was. Did the back of the book leave it like this, or did they round it to a decimal? Did it have pi in the answer, or was it a decimal? So this is fine though, because it doesn't say that you have to round. So this would be a good exact answer. If the directions were the exact same thing on a quiz or a test, I would accept that. Or you could go ahead and do 125 times pi divided by 11, or I could have just multiplied it in here. All comes out to be the same, about 35.700. Is that how they wrote it? Since the directions don't say, you could write it either way. I'm only going to be picky and pick up points when I ask for one and you do the other. Okay, so if you would, reflect on the first half of this question. Linear speed is angular speed times r. So I did angular speed times r. And then I just had to change it some units and change some units and change some units and change some units, and then I'll let my calculator do the multiplication.
Instead of 125
You spell 11 point what?
364.
Yeah, you don't want to do that because why round this fraction and then still leave it in terms of pi? If you're going to round, just get a decimal only. If you're going to leave it in pi, just leave it in fraction. Don't do like some kind of combination. I guess if the direction said leave your answer in terms of pi, I would still count that. Okay, good, because technically it's in terms of pi. Okay, so that was part A. Part B. What rate should it be set so that the tires can press it for 55 miles per hour? So I want to figure out what's the angular speed that's needed to make sure that my tires are balanced in the way or whatever they're testing here so that they can go 55 miles per hour. So the size of the tire hasn't changed. The formula of linear speed equals angular speed times r hasn't changed. But if you're having trouble getting started, that's what you got to do. Right after one formula, plug in 2 of the 3 things that you need. Now you've at least got something that you can solve with. We can divide both sides by 12.5 inches. And now I know what angular speed is. Now this is a big mess, so I do need to clean it up. And if it doesn't say what units to do, once again, kind of frustrating because my answer may not look immediately like theirs in the back of the book. Fine. This is called vertical format. But you have this fraction divided by this right at horizontal. 55 miles per hour divided by 12.5 inches. Fraction parts is division. And then you can just say, okay, wait, I'm dividing fractions, and anytime we divide fractions, can change it to multiply by the reciprocal. And I can start to multiply those numbers if I want to, but miles per inch hour is not very simplified. There's a way to get these two to cancel. Inches and miles are the same height. So, we multiply. Miles. So let's look at what happens when we do that. 12 inches is the same as 1 foot. (5,280 feet) is the same as 1 mile. So not only do the feet units cancel, the mile units cancel too. So now that I have no units left in my numerator, it would be radians. And the only units I have in my denominator are hour. So how many radians per hour? Well, that's fine. Radians per hour is a perfectly acceptable way to describe your angular speed. Miles per inch hours is not acceptable. So now, when my calculator do the computation, 55 times 12 times 5,280 makes up my numerators. Divided by 1 times 12.5 times 1 times 1 makes up my denominators. And so, in the back of the book, I think someone said that they didn't leave it in radians per hour, so they probably have a different number there. But there's nothing wrong with this. The directions didn't say I couldn't leave it in radians per hour. So, does anyone remember what units they left it in? So you could, and again, this is unnecessary because I've met the requirements of the question. But if I want revolutions, I could do this, and use it per minute, and I could do this, and then I could remultiply so that's about 739.498 if you wanted to change it to revolutions per hour. Does that match up with what they got? But again, you don't have to change it to revolutions per hour because the question never said you needed to change it to revolutions per hour. I'm perfectly fine with this stopping back here. That meets the requirements of the question. But to even start this, like if you struggle with the changing the units, you know, I try to model it this way because I think this is what works for most people. But you've got to be solid on how to start. You've got to know that formula. Linear speed is angular speed times r. You've got to undo timing 12.5 by dividing by 12.5, just like you did in algebra 1, to even get to this. But if you get to this, it's just converting the units to something that's acceptable or to something that they specifically ask for. Okay, so either part A or B. This was one of our longer questions. Any clarification, any detailed questions you want to ask in there? Or I'll let somebody else ask another one.